Hello, and welcome to Astronomy 100. In this segment, we're going to continue our discussion of the moon, and we're going to focus our attention on the lunar phase cycle. The phase cycle is how you see the moon change its appearance over time. One of the things you'll notice if you were to watch the moon on a daily basis is it seems to change its shape over a period of time, and it also seems to change the amount of its illumination over a period of time. So let's begin with an animation I have for you here. What you'll notice is this is a time-lapse sequence, if you will, that is showing you the entire lunar phase cycle. And a couple of things you'll notice. First of all, you'll notice that as the phase cycle completes and repeats over and over again, there's a bit of a wobble that you see. Now, the wobble is an illusion. The moon is not necessarily wobbling when it comes to its movement, but what's changing is how we see the moon over a period of time. And the moon has an elliptical orbit, and how we see it based on its speed and its movement and its orbit is going to create this little bit of a wobble, and it's called libration. The other thing I want you to notice is notice this portion of it that looks like a line. That's the difference between being lit and dark working its way across. The name of this line is the terminator. And don't confuse it with the movie series of the robot that doesn't ever seem to die. But in this case, the terminator is referring to the termination of daylight or the termination of darkness. And so this is essentially the dividing line between day and night. So as this is working its way across the moon, in this case, this is sunrise working across, followed by sunset working across. And any body in the solar system, the Earth, Mars, Jupiter, whatever, all of these bodies also have a terminator. Now, the other thing I want you to notice is as the moon continuously goes through its phase cycle, notice that you can see the familiar dark areas. We called these lunar maria in the last segment. And if you notice any of them in particular, just pick one. This is Mare Crisium right here. You'll notice that as the phase cycle changes, growing and shrinking, notice the features stay the same. In other words, the location of Mare Crisium is in the same place. Down here is the crater called Tycho. And you'll notice that Tycho is in the same place in every single frame of this video over the period of time. Now, what this is demonstrating is a very important thing, and that is the moon keeps one side facing the Earth at all times. So there's a side of the moon that we forever see, and there's a side of the moon that we will never see as long as we're stuck on the surface of the Earth. So the moon keeps one side facing the Earth at all times, and there's a side that is always facing away. Now, don't confuse that. There is no dark side of the moon. We'll find out more about this later on, but there is a permanent backside to the moon where there's one side that we see at all times and one side that we don't. Let me show you some of the stills that go with this. You'll notice that even though the phase or the illumination is changing, notice the surface features seem to be the same. They're in the same location at all times. So you can clearly see the evidence that the moon is keeping one side facing us permanently. Now, this begs the question that a lot of people struggle with, and that is, does the moon rotate on its axis? Remember, rotation is spinning on its axis. So the question is the moon an actual rotating body? We know that the moon orbits around the Earth, so we know that it's revolving around the Earth, but the question is it rotating? So I'm going to show you how to answer that, how to be able to show the case one way or the other. So I'm going to show you a video here in a second, but let's start off describing what you're about to see. In this video, we have the moon, and it's going to orbit around the Earth. And I want you to notice that we've put an artificial yellow peg. So we've just sort of arbitrarily stuck this peg in the moon. And when I press the play button, what's going to happen is the moon is going to orbit the Earth. But I want you to notice how the peg is going to stay pointed in the direction of sort of lower left the entire time. So let's go ahead and make this work. The Earth is spinning on its axis, the moon is orbiting around the Earth, and you'll notice that the yellow peg is pointed in the same orientation at all times. What you're actually seeing is the moon revolving around the Earth, orbiting, but it is not spinning on its axis. But notice, as it moves around the Earth, if it does this in the fashion you see here, we would see all sides of the moon. At some point, we would see the side with the peg, we would see the side without the peg. So notice that you can see this side of the moon from the Earth's perspective, then you're going to see this side of the moon from the Earth's perspective, and so forth. So in this example here, you can see that the moon is not rotating on its axis. However, we are able to see all sides of the moon if this were true. What we just saw a moment ago is that we do not see all sides of the moon. There is one side that is perpetually facing us and one side that is not. So the fact that the moon keeps one side facing us at all times is proof that it has to be spinning on its axis. Let me show you how, if we change it so that we keep that peg pointed towards the Earth at all times, how it's a very different scenario. Let's go to the next one here. So in this one here, what we're going to do is keep the yellow peg permanently pointed at the Earth. The moon is still going to orbit, still going to revolve around the Earth, but the yellow peg is going to be constantly pointed at the Earth as we do this. Now notice, to keep the yellow peg pointed at the Earth at all times, you have to make the moon rotate on its axis. So the moon has to spin, remember, spinning in place, so it has to perpetually spin to be able to keep that peg pointing at the Earth at all times. So to be able to show one side of the moon to the Earth at all times, the moon has to spin on its axis. So the very fact of what we see proves that the moon is rotating on its axis. But notice the type of rotation that the moon is doing when it exhibits what we see in the sky to keep one side of the moon facing us at all times while it orbits the Earth. There is a synchronization between the spin of the moon and the orbit of the moon. So notice, to keep this imaginary person with the Earth directly overhead at all times, the moon has to have a little bit of a turn, a little bit, as it orbits around the Earth. But notice that the person will go back to the same sort of downward position only when the moon gets all the way back to where it started from. So the spin of the moon on its axis is synchronized with the orbit or the revolution of the moon around the Earth. And this is what we call synchronous rotation. Synchronous rotation is when the moon's rotational period, meaning how long it takes the moon to spin once on its axis, is equal to the moon's revolution period, meaning how long it takes the moon to make one orbit around the Earth. So the time it takes the moon to spin once is equal to the time it takes for the moon to orbit once. That's what has been synchronized. The one thing I want to caution you is it has nothing to do with the rotation of the Earth. A lot of students make the mistake of thinking that the spin of the Earth on its axis is somehow related to this. Let me kind of show you how it's not. If you remember from a previous segment, we talked about how it takes the moon about 27 days, 27 and a third days to go all the way back to its original position. So that means the Earth has to spin 27 times, a little more than 27 times, while the moon makes one single orbit around the Earth. So when we say synchronized, it's not synchronizing the spin of the Earth. The only thing that is synchronized is the spin of the moon with the orbit of the moon. The other mistake that students will make is they'll say it's the speed of the moon's orbit synchronized with the speed of the moon's spin. It's not a matter of speed in this case, it's the time period. So the time that it takes for the moon to go all the way around once is equal to the time that it takes the moon to orbit the Earth once. So make sure you keep those ideas clear. Now what this boils down to is that there's going to be a side of the moon that is, as I said, perpetually facing the Earth. And the side of the moon that always faces us is going to be, of course, the familiar side that we see at all times. We often take that side for granted. But let me show you a couple of cool pictures here. So here is a nice photograph of the full moon. And what I want you to notice is the side we always see, the lunar Maria, it's the familiar looking full moon. But unless you're an Apollo astronaut, or unless you send a robot to the moon to go orbit around it to look at the backside, there's a side of the moon that you'll never see from the surface of the Earth. Now, luckily, we have sent many robots around the moon over the years, and these robots have taken lots of pictures, and we have nice maps, if you will, or photographic pictures of what the backside of the moon looks like. And here is what it looks like. Many people are surprised. Notice how very different the backside of the moon looks compared to the near side. I'm going to go back and forth here. So here's the side always facing the Earth. Here's the side that never faces the Earth. Now, there are a few artifacts I need to explain. First of all, you'll notice that it looks, if you look very carefully, it looks kind of striped. That's actually part of the photography. The way that it works is there's a spacecraft that orbits around the moon, and as it goes around in the moon over and over again, it takes picture, 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 picture as a stripe. And then as the moon is slowly rotating on its axis, the next go around, it's a new stripe. It's just that when they digitally put together all these pictures, they could have done a better job cleaning up those stripes. So the stripes are artificial. But what I want you to notice is how the backside of the moon seems to be lacking lunar maria. Notice the maria, these dark impact craters filled with now solid, once lava, once liquid lava. And what we now have is that, of course, the side facing us has all of these features. But if you look at the backside of the moon, there's just a few. So the moon's backside has less lunar maria compared to the near side. And the reason for that is because the interior of the moon is not perfectly symmetrical. And so in an era when you were able to have something hit the moon and then be able to get to that liquid lava and have it bubble up to the surface, there's a thinner crust on the side facing the Earth and a thicker crust on the side facing away. So impacts on the backside, we're not able to tap into the lava quite as easily, whereas impacts on the front side or the near side were. So you can see that there's a lot more lunar maria. Now, the last little thing I want to mention is, even though Pink Floyd made a really great album called The Dark Side of the Moon, I want you to see and notice that there is no such thing as a dark side of the moon. For instance, this is half of the moon being lit by the sun, and this happens to be the half that we always see. And this is half of the moon, again being lit by the sun, and again, you'll notice that it's completely illuminated. And unless you have more than two halves to make a whole, you have a front half and a back half, there is no side permanently in darkness. There is a side that is permanently the back side, but there is no such thing as a permanent dark side to the moon. Nice idea, but it turns out to just simply not be correct. So as you can see, the moon has some interesting surface features, and of course the way that we see the moon as it orbits around the Earth, constantly showing the same side, proves to us that the moon has to be spinning on its axis to continually show us that same side at all times. A little bit confusing because it's tempting to think that it doesn't turn, but it turns out that it does. Now, in the next segment, we're going to concentrate on those phases of the moon, the difference in the appearance, the shape, and the size of the moon over time, and we're going to see how the phase cycle works. We'll talk about the terminology, and we'll put it all together. I hope you'll join me.